What we're going to do today is we're going to think about what derivatives look like graphically. And we remember that derivatives give us the slope of the tangent line. So we have to figure out how do we translate that into graphing the derivative as a function. So we remember we've thought of derivatives are going to be functions in their own right. And so how do we graph the corresponding function? So we're going to do a few examples here, kind of get an idea of what's happening. I'm actually going to look at that second graph, kind of looks like a cubic function. So the easiest place to start when we think about graphing the derivative is where is the derivative going to be zero? We remember that the derivative is the slope of the tangent line. So if I look at this function, the derivative or the slope of the tangent line will be zero here and here. So if I'm going to graph the derivative, I'm going to put that the derivative will be zero at each of those places. Okay, and now we have to figure out where's the derivative going to be positive, where will it be negative? These are the only two places it's going to be zero. So let's look between those 2 points. Let's look in kind of this region here. So if I look at slopes of tangent lines of any point along there, if I'm going to draw my little tangent lines, I've got like a little tangent line here, here, here. All of those little lines have negative slopes. So the derivative is going to be negative between these 2 points. And we notice that the derivative, this slope is a lot shallower, a lot less steep than this slope. And this one's pretty shallow too. So what it looks like is we're going to have bigger slopes here and a small negative number here. Okay, and so what that kind of would make sense is if we have something like this, we just join those 2 points. So these are all negative numbers, so the y values are negative, and kind of we have smaller negative numbers, bigger negative numbers, smaller negative numbers. Okay, so the thing that I'm graphing right now is I'm graphing the derivative. The y values of this graph that I'm giving here should be the derivatives of the original function. Okay, so now if I look over here, the slopes, if I draw slopes of my tangent lines, I have positive slopes. Each of those little line segments I just drew have positive slopes. These are smaller slopes. They're not as steep, and the slopes get steeper or bigger numbers as we keep going. So we want positive numbers that just keep getting bigger. So we might do something like this. The same thing is going to happen on the other side. If I look at the slopes here, I have a small positive slope, a bigger positive slope, a really big positive slope. So the y values of the derivative should be small positive numbers getting bigger. So maybe something like this. So this is the graph of the derivative. Okay, so the graph of the derivative is telling us the y values on the graph of the derivative are telling us the slopes of the original function. Okay. So let's look at these 2 other examples. So this first example, the only place where the slope is 0 is at the origin itself. For all the values over here, the slope is positive. So we do a little tangent lines. These are all positive slopes. So we might have something like this. If you drew a curve here, that's okay for now too. And then over here, the slopes are all negative. We have steep negative slopes, less steep, less steep. So we should get maybe something like this. I have enough inside information that I know this is going to turn out to be a straight line. If you do something maybe a little bit curvier like this, that's okay, as long as you have negative values, negative y values on the left, and then positive y values on the right. Okay, let's keep going. So this next one has a lot of places where the slope is 0. So maybe here, here, here. The slope is getting pretty close to 0 over here. It's probably not perfectly 0, but it should definitely be getting closer to 0. And so now let's look at what's happening in between. So between here and here, we have positive slopes. The biggest positive slope seems to be around here. So we maybe have something like this. These, whoops, over here, if I draw my little line segments, those all have negative slopes. And then we're back to negative slopes between here and here. Maybe the biggest negative slope occurring somewhere around here. So that's going to be our low point. And then we have positive slopes again. Our biggest positive slope appears to be maybe around here, and then the slopes are still positive, but getting closer to 0. So we're going to have our biggest positive number and then coming back down. This one's kind of interesting. We noticed that we had a horizontal asymptote on the original function. It's actually going to correspond to a horizontal asymptote on the derivative of f prime as well, because things are flattening out there. And now this last one has a bunch of straight lines to it. So we can actually figure out exactly what the slopes of these lines are going to be. So if I look at this whole line segment here, the slope of that line is, let's see, that looks like a +2. We run 2, or rise 2, run 1. So what that means is that the derivative from x equals -1 to x equals 1 is just 2. So if I'm going to graph that, I'm just graphing 2. The derivative is 2 for that whole region. Something funky happens here because the derivative has this quick change. So I'm going to put open circles at x equals 1, and we can talk more about that in class. The slopes along here are -1. So that means the derivative is -1. Slopes along here are 0. So that means we're getting 0. Oh, sorry. That last line segment should have gone all the way from here to here. And then we're getting 0 from here to here. And then this last little guy, the slope of that line looks to be -2 to me. So we're going to get down here. Oops. Make sure the x values correspond. So we're down here at -2. Okay, so this one's this like weird little piecewise graph. So if this doesn't make complete sense to you right now, hold on. In class, we'll do a lot more examples like this, and hopefully it will make more sense. So what we're doing when we graph derivatives is we're essentially graphing slopes of the original line. So we're saying, what are our slopes? The y values of the derivative or slopes of the original line.